Assalamualaikum and hi everyone. This video is to help you to learn and understand more about functional groups and structural isomers. This is one of the subtopics in Chapter 4, Introduction to Organic Chemistry. Let's start with all of these structures. If you can see on the screen, there are 16 structures with different functional groups. Can you guess what types of functional groups in all the structures? Let's start with the first structure. This structure has carbon-carbon double bond functional group. So you can see this carbon-carbon double bond in this compound. The second one, we have carbon-carbon triple bond. This is halogen functional group, which is group 17 in periodic table. This OH group, we call it as hydroxyl group. The 6-membered rings here is named as aromatic ring. So this is a functional group of aromatic ring. The oxygen in between two alkyl groups, we call it as alkoxy group. The C double bond O here named as carbonyl functional group. This one is also named as carbonyl functional group. If you can see, these two structures have same name of functional groups but different compound. This C double bond O is attached in between of two alkyl group, while this C double bond O at the terminal of the compound with H atom attached to this C double bond O. This is we call it as aldehyde compound, while this one as ketone. Both have same functional groups, which is carbonyl group. The OH group, which attached to benzene ring, this one, we also call it as hydroxyl group. This is from the phenol compound. The group with C double bond OOH, we call it as carboxyl group, while C double bond O with O and alkyl group attached to this O is named as carboalkoxy. Next, C double bond O with NH2 group, call it as carboxamide. The C double bond O, which attached to this chloride ion, we call it as acid chloride or acyl halide. While when we have C double bond O, C double bond O, is named as anhydride. The NH2, which attached to alkyl group, we call it as amino functional group. And the last one, C triple bond N, named as cyano group. So there are 16 functional groups that you have to remember, and you have to know the structure of each functional groups. Let's try with this example. Can you guess functional groups exist in all of these three compounds? In the first compound, we have this group, 6-membered ring with alternate double bond. This is what we call as aromatic ring. This is aromatic ring. The second one is we have O in between two alkyl groups, so we circle it like this. We call it as alkoxy group. Next, in this structure, we have NHCO. NHCO here. CO here represents C double bond O. C double bond O that attached to N. So, this group is carboxamide in the homologous series of amide. Next, in this structure, you can see the C double bond O, which is carbonyl group. Then we have C double bond C. So this is C double bond. Next, we have this group, same as this one, 6-membered ring with alternate double bond. We call it as aromatic ring. We also have this halogen. Then we have CC triple bond. We also have carboxyl group. And next, we have this one, C double bond O, O, an alkyl group here, named as carboalkoxy in the homologous series of ester. This one is carbonyl group in homologous series of aldehyde. Okay, let's look at the last structure. We have this 6-membered ring with alternate double bond, which is aromatic ring. This OH group is hydroxyl group, and this NH here is for amino group. So you can check your answer. Actually, this is the example in your tutorial question. Take note how I circle the functional group, because you will apply this knowledge in your assignment when you want to answer your assignment question. Maybe it may ask you about the functional group in the compound, so you have to circle all the functional groups. Okay, next thing to be discussed in this video is about the isomerism. We start with definition of isomer, the existence of chemical compounds that have same molecular formula but different molecular structure. We call it as isomer. Let's look at types of isomer. We have two big groups of isomerism. The first one is structural or constitutional isomerism, and the second one is stereoisomerism. For structural isomer, all the compounds that are said to be structural isomer has different in connectivity, while for stereoisomerism, the compounds have same connectivity but different arrangement in space. In structural isomer, we have three kinds of structural isomer, which is chain isomer, positional isomer, and functional group isomer. While for stereoisomer, we have distereomerism or cis-trans isomerism, and we also have enantiomerism or optical isomer. But in this video or in this session, we only will discuss about this kind of isomer, which is structural isomerism. Okay, let's start with chain isomer. Okay. For example, let's say I have a molecule with the molecular formula C4H10. So I have two molecules with C4H10. Let's say this is the first molecule. I have this straight chain of C4H10. I name this structure as A. And I have another structure with C4H10, but for this A structure, I have 4 straight chain as the longest chain. But for the second structure, I shorten the straight chain from 4 carbon to become 3 carbon, and another 1 carbon has become the branch, like this. And I named this structure as B. So A and B have same molecular formula C4H10, but has different structure. A has 4 carbon as straight chain, while B has 3 carbon as straight chain with 1 substituent. So A and B are said to be chain isomer. Okay, you have to remember that for us to classify the types of isomer, there must be a pair of structure. So we must have 2 structures so that we can group them as isomer. We cannot just assign one structure as our isomer. There must have at least 2 structures so that we can classify the structures as constitutional isomer or structural isomer. Alright, let's go to the next types of structural isomer, which is positional isomer. Let's say I have C4H10O. C4H10O, and I have my first structure with 4 carbon and OH. So let's say I named it as structure A. Okay, if you look at this structure, I have this OH attached to this carbon, to this first carbon. Now I want to draw another structure with 4 carbon also 4 carbon, but this OH, I have changed the location into the second carbon. I put it here, so I will have another structure, and I named it as B. A and B both have the molecular formula as C4H10O. Both have same longest straight chain, which is 4 carbon, but the position of functional group for A is at carbon number 1, while for B is at carbon number 2. So A and B are said to be positional isomer. Alright, let's say I have another structure. I also have 4 carbon. The A structure has OH at this carbon, B structure has OH at this carbon, while this structure I put OH at this carbon. Okay, and I name this structure as C. Okay, can you classify this structure? Is it isomer with B or isomer with A? So if you look at A and C, A has OH group at the first carbon here, while C has OH group at this carbon. So A and C are said to be positional isomer. But if you look at B and C, this B has OH group at this carbon, while C has OH group at this carbon. Although it looks like different structure, but actually both B and C are same structure. Even though this OH group is attached at this carbon, but we will assign this carbon as our second carbon as this structure. So carbon will number, the first carbon will number by the nearest to the functional group. So this will be our first carbon, this will be second carbon, third carbon, fourth carbon. For this B structure, this will be our first carbon, second carbon, third carbon, and fourth carbon. So we can see B and C have a functional group attached to the second carbon, and B and C are same structure. Okay, next is about the functional group isomer. For the functional group isomer, there are pair of functional groups to be classified as functional group isomer, and you have to remember these pairs. For example, compound of alcohol will have a functional group isomer with ether compounds, aldehyde with ketone, alkene with cycloalkane, while carboxylic acid with ester are said to be functional group isomer. For example, I have C4H10O. Okay, just now we have this structure as our first structure. So this is alcohol. I name it as A. So when A is alcohol, it will have functional group isomer with another compound. With alkoxy, it will have functional group isomer with alkoxy compound. So I have another structure with this alkoxy group. And I name it as B. A and B have same molecular formula C4H10O, but A has hydroxyl as functional group, while B has alkoxy functional group. So look at these pairs, alcohol and ether, A as alcohol, B as ether. So A and B are said to be functional group isomer. Let's try another structure. So let's say I have C4H8. C4H8 is a compound with C double bond C. C double bond C is an alkene. So its pair is cycloalkane. Let's say I name it as C. So I have another structure with C4H8, but it is in this structure, which is cyclobutane, or it is as cycloalkane. I name it as D. Both C and D have same molecular formula C4H8, but different functional group. C has CC double bond, while D has no functional group. It is a cycloalkane. So C and D are said to be functional group isomer. Okay, another structure can also be as functional group isomer for C with C4H8. It can also be a cyclic compound with 3 carbon with 1 branch. I name it as E. So C and E are also as functional group isomer, as E has 4 carbon and 8 hydrogen, same as compound C. So these pairs is the one that you have to remember so that you can assign your compound with its functional group isomer. Now let's try this exercise. For each of the following compounds, draw its isomeric pair that represent a chain, positional and functional group isomerism. We have 4 structures here as the example. Okay, let's look at first structure, structure A. Structure A has 1, 2, 3, 4, 5, 6, 7. 7 carbon as longest chain with 1 side chain here. So it will have chain isomer. For example, this is a chain isomer for this structure. Now I have changed the longest chain with 1, 2, 3, 4, 5, 6, 7, 8 carbon as longest chain. This one, 7 carbon as longest chain with 1 side chain, while this one has 8 carbon as its longest chain. Both still have same molecular formula and these two structures are said to be chain isomer. For positional isomer of this structure is, I have changed this CC double bond. For this structure, the CC double bond is at 2nd and 3rd carbon, while I change it to 1, 2, 3, 3rd and 4th carbon. So the position of CC double bond have changed, and these two structures are classified as positional isomer. And the last one is a functional group isomer. So the alkene compound, its pair is cycloalkane with the same number of carbon. So I have this structure, cycloalkane, with also 8 carbon, and these two structures are classified as functional group isomer. Let's look at B. B is compound with OH group. Okay, let's withdraw the chain isomer. The first structure, let's say I name it as A. A, we have longest chain as 1, 2, 3, 4, 5, 6, 7. Okay, 7 as longest chain. And for chain isomer, I have shortened the longest chain, become 1, 2, 3, 4, 5, 6. 6 carbon with 1 side chain here. And I name it as B. So A and B are chain isomer. For positional isomer, I maintain the longest chain as 1, 2, 3, 4, 5, 6, 7 carbon, but I change the position of OH group from 1, 2, 3, 4, 4th carbon to 2nd carbon. And I name it as C. A and C are positional isomer. For the functional group isomer, the pair for hydroxyl group is alkoxy group, and I draw the compound with O in between two alkyl group, but with the same number of carbon with A. I name it as D. So A and D are classified as functional group isomer. Next compound, I have C double bond OOH as my functional group here, and with 1, 2, 3, 4, 5, 6 carbon as longest chain with 1 side chain. So how I write the chain isomer for this compound? I name it as A. I have make the longest chain become 1, 2, 3, 4, 5, 6, 7 carbon, longer than A but still have the same number of carbon. So A and B are chain isomer. Positional isomer for the carboxyl group is none because carboxyl group, it must attach at the terminal of the compound. The carboxyl group, we cannot change the position in between two alkyl group. So there is no positional isomer for carboxyl compound. Functional group isomer for carboxyl is carboalkoxy or ester, and I will draw another structure with C double bond O, O, CH3, but I maintain the number of carbon with A, and A and C are said to be functional group isomer. The last structure, I have this functional group, which is carbonyl group, and it is ketone. So my chain isomer is I change the longest chain, I shorten the longest chain and with one side chain, but I maintain the number of carbon. Same with A. Say this is B. A and B are chain isomer. For positional isomer of A, I will change the position of C double bond O. A, the C double bond O is attached at third carbon, while for this D structure, I have changed the position of C double bond O to the second carbon. So A and D are classified as positional isomer. And the last one is about the functional group isomer. So this is carbonyl group as ketone, and the pair for the functional group isomer for this compound is also carbonyl group, but now this compound as homologous series of aldehyde. The molecular formula of A and E are same, but the structure E as aldehyde while A as ketone. So A and E are functional group isomer. So hopefully all of you can understand about the functional group and the structural isomers from this video. And I already prepared some extra exercise for you in our Google Classroom. And I hope all of you can finish all the exercise and submit the exercise in the Google Classroom within the due date given. Okay, thank you class. That's all for this video. Bye.